Hey guys, it's Coach Carroll here again to guide you through this lab that talks about how do you make assemblies using Autodesk Inventor. We're using Autodesk Inventor 2014, and this is the assembly that we'll be working with today. So we'll go through the whole process of how do you place these components in this assembly, how do you constrain them so that the machine actually acts in the way that it would in reality. So these assemblies are very nice because once you make the parts, you can put them together in an assembly and see to some degree how the machine actually works before you ever have to go and physically make it. Okay, so to get started on this lab, you should go to Moodle to download the files. So here's my Moodle site. For the class, go under the Assemblies and Bill of Materials section and click on this piston press for students. These are the files we'll be working with. So click on that and download it. So when you download it, it will download a zipped file, and you need to extract those files so that you can work with them. So just double click on it and click on extract all here. So I'm going to extract all the files in that zipped folder. I'll go back to downloads, and you can see it has uncompressed all the files and put them in this folder here. Now I'm going to move this folder out of my downloads folder and go put it in an appropriate place. Your files should be very organized for this class. So let's put it in an appropriate place. I'll cut it from here. I have a folder for this semester, fall 2015. Put it under the Engineering Graphics course, under the Bill of Materials and Assemblies, and I'll put it under Labs for that. Let's just paste it here. Okay, so this is what you'll be working out of. Here are the files. Here are the files we'll be working from. Okay. Now, in your lab document that you have a few pictures here that show you how the assembly is put together. It's three drawings that you have. This one for the cylinder body subassembly, and then this picture as well for the piston rod subassembly. Okay, so let's look at our main one here. There's a parts list at the top of the drawing here, and we have balloons pointing to the different parts within the assembly. And look at this bullet 2 here, this balloon 2. It points to this thing here. So what is that thing? Come up to item number 2. The QTY stands for quantity. There's one of them. And it's named a cylinder body subassembly. So this whole part here is actually another subassembly, which you have a separate drawing for. And that's described in this drawing. So within this cylinder body subassembly drawing, well, now this subassembly has several different parts to it. It has these bolts here. There's 4 of them. It's item number 4. There's 4 of them. Here's the part number. It's M5 by 120 millimeter threaded rod. There's 4 of those. Now, if you also notice in here, number 6 points to this blue piston rod. Well, that's actually a subassembly as well, so that piston and rod subassembly. So now if you go to the other picture in your lab document, this is the drawing for the piston and rod subassembly. Okay, and it's made up of 4 different parts here. Okay, now I do this, we have 3 different pictures, because if I were to try to show you every part individually within this assembly, it would get very complex. This parts list would be very long. I have to add up all the parts, but there would be a lot of parts. It would be confusing to show, and it would be difficult to see how things fit together. So it's much better in drawings for assemblies if you show drawings for each subassembly. So it's much smarter to make different subassemblies that fit well together, and then you put those sub-assemblies in together to make your full assembly. Okay, so these are the drawings that we're going from. Okay, so let's come up and make a new file here. So go to File, New. You want a new assembly file. Okay, so I've made a new assembly file here. All right, now which subassembly am I going to start with? Should I start with this one here, the cylinder subassembly, or this one? Well, I would start with the lowest subassembly. What I mean by that is this is the highest, most complex one. This this main assembly has one subassembly inside it. So let's look at that subassembly, number 2. Well, here's that subassembly, but this subassembly has another subassembly with inside it. We go down to that subassembly and it only has parts. So this is the lowest level. So this is the one I'm going to start with here. Okay. So we'll start with this piston rod. Okay. You can see there's part numbers here for each one and the descriptions for them. So I'll start with the piston rod. That's this blue rod here. So back in your assembly environment, you want to place a part. So click on Place. Now you'll have to navigate to where your folder is. I'm going to navigate there very quickly. Fall 2015, under Graphics, Labs. Here it is, Piston Press for Students. Okay. So you've navigated to where your folder is that contains all your parts, and I want to click by placing this piston rod. Notice it gives you a preview of the file that you're placing here. Click Open, and here's the piston rod. Okay. Now I'm going to right click and hit Place at Grounded, or Place Grounded at Origin. Okay. And now I'm just going to, I can either hit the Escape key now, or right click and hit OK. So what this did is it took the origin of the part and aligned it with the origin of the assembly file. Okay, so there's the piston rod placed in there. If you're having trouble rotating, to rotate you would hold the Shift key, hold it down, and then click and hold the center button on your mouse, and you can rotate the view very nicely. Okay, now what other part is in here? What's this part number 2 here? This is the piston. Okay, so let's go find the piston and place it. We'll go to Place, scroll down, find the piston there. We'll place that piston in here. I'll just click it one time and hit the Escape key. Now this piston, it's not the same on both sides. It's a little different. So let's look at our drawing and see which way should it go on this piston rod. Should I locate it like this or this way? Which way? So just come back to your drawing. Okay, you can see here's this the bigger counterbore hole within the piston makes room for this nut here. Okay. So, if I click on this Free Rotate, okay, we'll click on Free Rotate, and now click on the part that I want to rotate, so select that part. Now I can click and hold the left mouse button and rotate it. So I want to do this to position the part in the approximate orientation that I'm going to assemble it. So I'm going to assemble it about like this. Okay, so let's let go there. Press Exit to get out of the Free Rotate tool. Now let's add a constraint. So click on the Constraint tool. Okay. Now the first constraint I'll add is I want the center axis of the piston rod to align with the center axis of the piston itself. Click that, and now click OK. And notice these are always aligned now, but I have not. You can click on the piston and still drag it up and down. Okay, so I have not said where it is up and down yet. Okay, now to do that, when I do that, I want this face to be constrained to this face here. Okay, so click on constrain, and I'll constrain this face to meet with this face here. Now press OK, and there it is. Okay, so is this fully constrained? Well, I still can rotate it, but that's okay. Okay, you only want to apply enough constraints as necessary that are appropriate for the connection type. Okay, don't forget to save your work. Notice my little save reminder popped up here. I have not saved my work, so that's a good reminder. Forgot to do that. Let's click Save now, and make sure to save it in the same folder that all your files are in. So I'm going to navigate to the same folder that all the part files are in. The labs, piston press for students. Now I need to save it here. I'm going to call this one. This one's the Piston Rod Subassembly. Hit save. Okay, so if you haven't done that yet, make sure you save this. Okay, what else to do? Let's come back and look at our pictures here. Well, now there's a nut, and there's this lock washer, really. They call it a metric tooth. It's a washer that keeps the nut from unscrewing if the piston vibrates. So let's put this nut in, or sorry, not the nut, this tooth here. This is part number 3. See, pointing, it's kind of hard to see, but right here, it's the metric tooth, LW, is what I'll put in next. Okay, so let's go to place, go find that. Where is it in here? Not a threaded rod. Is it one of these? There it is. Was that the part number? Let's go check the part number. Part number is AS1969-M8. And that's what this is here. Okay, so hit open, place it, hit escape, so you don't place more than one. So you can see what this is. It's a little washer. Okay, it's a little lock washer. So let's constrain this. Click on constraint. Move that out of the way. Again, I want the center axis of this lock washer. Now be careful. If I clicked now, I'm not actually selecting an axis. I'd be selecting a center point, is what popped up there. That's not what I want to constrain. I want to constrain axis. So make sure you select this face. You see that red line pops up, which is the axis. So select that axis and constrain it with this axis here. Now hit OK. Now it's constrained there. The axes are constrained, but it can still rotate and slide up and down. So now let's add another constraint. Make this bottom face, say we want that to meet with this face here, and hit OK. Now it's constrained there. Now I can notice I can still rotate it, but that's okay. Again, there's nothing that will prevent that rotation, okay, which is fine. You don't want to add more constraints than necessary. Now let's go through and actually add this nut number 4 here. Okay, it's a ANSI B18.242M. Let's go find that. So again, place a component. One of these, there it is there. Open, click one time, hit escape, Is this nut symmetric on both sides? Yeah, it appears to be, so there's really not any preference to say which side, either this side or this side, is flush with this lock washer. So I'll click on constrain, I'll select that axis with this axis, hit OK. Slide it up so I can see this bottom face here. Click constrain again, and I'll constrain this face with, now don't constrain it to this face, okay? This washer will fit tightly or snug up against the face of the washer there. Click OK. There you go, now that is constrained. Okay, now notice with this constraint, if I turn the washer, or sorry, turn the nut, it does not unscrew, which is okay. You say, well, in reality, if I were to turn this nut, it would come off of the piston rod. Yes, that's true here. You could add more complex constraints to actually make that possible, but we're sticking with very simple constraints, just that you can see the placement of parts relative to one another. Okay, so that's all the 4 parts within this subassembly. So let's click Save. And now I've saved that subassembly. So there's one of the subassemblies. Now let's create this second subassembly. Not that one. Here we go. Let's create this subassembly now. It's a cylinder body subassembly. Okay? Alright. Now, which part would I want to place first when I'm making this? You say, well, how is this thing going to move? Let's look. I've already got one open that I've made here. And here it is. You should be able to grab this piston rod and slide it inside and out of the piston body itself. Okay? So this little subassembly that I just created, this piston rod subassembly that I'm sliding now, that's going to move. In the first part that you place in an assembly, you typically want it to be grounded. You want it to be a base part that will not move. But since this subassembly will move, I don't want that to be the first thing I place. So I'm either going to place this cylinder head cover or this base cylinder head cover here. I think I'll choose this one here to be the first one. Okay? So let's again look at our picture. This is what you have. And again, I say this piston rod subassembly will move. So let's either place this piece, number 3, or piece number 1 as the first part so that it will be grounded and not move. Okay? Alright, so number 1 is TU001. It's the cylinder head back, or cylinder head cover back. Alright, so I'll create a new assembly. So you go to File, New. Alright, what am I creating? I'm creating an assembly. I want a standard assembly. That's a millimeter assembly here. So a standard millimeter IAM. Hit create. Okay, now before I forget, let's save this. It's going to be the name, cylinder body subassembly. So let's save this first. First thing I do. Cylinder body subassembly. We'll save that. Okay, now let's place a part. Click place. And again, I said I'm going to select this back cover first, the cylinder head cover on the back. So hit OK. Now again, I want to place the origin of this part on the origin of the assembly environment. So right click and just hit ground it at origin. Okay, hit OK. Now I'll hit escape, and I've placed it. Now what does grounded mean? Notice over here on this part in the part browser, it's got that little thumbtack next to it. So that means that that part is grounded. Okay, so it can't move in reference to the origin of the assembly coordinate system. So here's the XYZ plane of the assembly coordinate system, and here's the YZ plane of the part itself. It's the same plane because I selected grounded at origin. Okay, what would be the next logical part to place? Well, you say, what touches this cylinder head cover here that we just placed? Well, these bolts do, okay, but I don't want to place those yet because I don't have anything to connect them to number 3 here. So I'm going to select this green part here. That green part, number 2, that's the cylinder tube. Okay, that's what the cylinder slides inside. So let's place that next, okay, because it has an easy connection to our first part. So I'll go to place. And let's find the cylinder body there. Click OK. I'll just click anywhere in here and click Escape. Alright, so let's constrain this. I'll click Constrain. Again, the first one I'll do is an axis constraint. Let's find this axis. Constrain those axes. Hit OK. Now you can see it can slide up and down on that axis. But now let's constrain this to actually fit flush with this cylinder cover here. Alright, so move it up a little bit so I can see the faces. I want to constrain this face with this face here. Okay, notice when I'm selecting the faces, there's an arrow that's normal to that face. That face normal. Okay, so I'll click on that. And now click OK. Alright, now let's place the next part. So I'll place now the other cylinder head cover, the one on the front right here. And so part number 3. Okay. Again, this is the next logical connection. It's what connects with connects on the other side of the cylinder body. So again, go to place. Go find the cylinder head cover on front, hit OK, click once and Escape. Alright, now I want to orient this part in the approximate orientation that's about where it will be constrained to this body here. So it's not going to fit like this, right? I need to rotate it. So let's click on Free Rotate, select this part, and actually rotate it to where it's about where it's going to fit. Okay, it'll fit about like this. So now I'll click Escape. Alright, now we can do a constraint. So let's constrain this center axis to that center axis. This time I hit Apply. Okay, so when I did that, I did not actually get out of the constraint tool here. Okay, but I'm going to click Cancel because the next constraint I want to add is on, let's say, this face and one that I can't select here. Okay, because of the placement. So let's hit Cancel and let's move this up out of the way. I do that just so I can actually select this face here. Now I'll go back to Constraint, constrain this face with this face here. Alright. Now, hit OK. There you go. Okay. Now, notice I can still rotate this. Okay, I've not constrained that rotation. Now, what's going to constrain that rotation? It will actually be the bolts that go through here. Okay, so I could add another constraint to make, let's say, this plane aligned with this plane, but I don't want to do that now because in reality that's not what will constrain the rotation of this top head cover. It will actually be the 4 bolts. Okay, so now let's put those 4 bolts in next. Okay, so let's go find one of those rods. What's the name of it? It's number 4. It's this M5 by 120 threaded rod. So go to place and find that threaded rod. There it is, M5 threaded rod. Hit OK. Now I know we will place 4 of them overall, but let's start out just by doing 1. Okay, so I'll just click 1 time and hit escape. Alright, now one thing to notice on this assembly, look, this bottom cover actually has this little threaded hole here. Okay, and there's also a threaded hole up on the top one as well. There it is. We want those to be on the same side of each other. Okay, about like that. So let's go look at our picture. You can see that here. This hole and this hole are on the same face. Okay, so make sure you've got those aligned before you put a bolt in. Okay, so now let's put this bolt in. Go to constrain, and again let's constrain this axis of one of these holes with the axis of the bolt. Okay, so this bolt can slide up and down, but notice I haven't constrained the axis of this top one up here yet. So now let's do that. Go to constrain again, constrain this axis with the bolt axis. Hit OK. There you go. Now notice I can't rotate this top piece anymore. Okay, which is good. That's actually how we want it. Now it can slide in and out like this. So the question is, well, where do I put this rod? Do I put it? Do I drag it up here? Drag it down here? Where is it? Well, I actually want it right in the middle. I want the same distance of the rod coming out on this side as I do on this side. Okay, so for this constraint, it would be nice to use planes here. So I'm going to look for a plane on this green body. Okay, if I right click on the green body, sorry, I thought there was a show in browser. Where is that I'm looking for? Bill of materials, don't see that. It's okay. Anyway, look over here in the part browser. If you look in the part browser, there's that cylinder body there. Okay, so I'm going to expand that cylinder body. Okay, let's expand that. And let's look at the planes on this cylinder body. There's one, there's the YZ. Here's the XY. Now this XY plane actually goes through the middle of the cylinder body. I'm going to turn that visibility on. So right click on the plane and select visibility. So I would want that plane to match with the plane that goes through the middle of this threaded rod. So click on the plus sign to expand the threaded rod. We'll click on the origin of the threaded rod and look at these axes. There's YZ, XZ, not that one. There's a YZ plane. Again, I'll right click and turn visibility on. So I want those two planes to be in line with each other about like that. Okay, so we can do that. Just hit constrain. Now that I have these two planes, I can select this plane and that plane. Alright, hit OK, and those planes are locked together now. Okay, so now if I would try to slide this rod up and down, I can't do it. Okay, the only degree of freedom is rotation like this. Okay, and that's alright. I'll turn the visibility of these planes off now. Let's turn that visibility off and this one as well. Okay, so that's how you can use planes to actually constrain parts. Alright, now I want to do that 4 times, right? I want to put this over here, here, and here. So basically 3 more times, alright? Now I could go repeat that process 3 more times, and that's not bad, but when you have, let's say, 50 of those, well, that may take a lot of time. So even in the assembly environment, I have the pattern and mirror features here. So let's try to use those. I'm going to use the pattern feature here. So let's select on pattern. Okay. Now, I'm going to select on this rectangular pattern. The reason for that is these 4 holes here where the bolts will go is in a nice rectangular pattern. Alright, the first thing it wants me to select is what component do I want to pattern. I want to select the threaded rod. So select that. Now I can click on this arrow that says what's the column direction. So I'll click on that arrow. Now if I click on any edge, notice if I have this edge, I just have my mouse hovering over that edge and there's an arrow there that you will see. You'll see that arrow pop up. So click on that and that's going to be the direction that it will choose to pattern it. And I want to pattern it this way. Let me change the distance and it'll make it more clear. Let's change that. Let's make it 20. Okay, so you see it's patterning it that way. If I click on this one, well, the arrow's pointing in the wrong direction. You can see the arrow's pointing to the right. If I select that edge, I could select this edge here. And now it's pointing to the left. That's good. So let's select that. And again, I could change these. So change these distances here to where it actually would pattern to these holes. But I don't know what the distances are. Is that given in your drawings? Is it given here? No. Not there. There's no dimensions here. Okay, so I need to figure out how far do I actually pattern these bolts to where it'll match up with those holes. I don't know that now, so let's hit cancel. Okay, we can now. I need to go find out how far are these holes. Okay, well, if you go under inspect, click on the inspect tab. There's this distance measurement right here. What it does is, it measures a length or distances. Okay, so I'll click on that. So I want to measure the distance between this hole. So click on that hole and this hole here. Let's select that. It's a distance of 33 millimeters. Okay. And what distance is that? It's not showing me. Whoop. Sorry, I clicked escape. Again, click on distance and let's say this hole and this hole here. Okay, it should give you a little line. I'm not seeing that line. I'm going to try something else to get it to work here. Say between there and there. It's giving me a diameter. Diameter is 6 millimeters. Anyway, from there to there. Okay, this 33 millimeter distance, I was hoping there'd be a line, which there's the line. Okay, sorry, it was hard for me to see. If you rotate around to the back side, see this blue line right here. Okay, this blue line is showing you what it's measuring. And notice it's not actually measuring between the center of this hole to the center of this hole. It's actually measuring between this edge of the circle and this edge of the circle. So the closest edges together. That distance is 33 millimeters. Okay, so that's not the distance I want to pattern. So let's click on distance again. I want to go that distance. Now what's the diameter of this hole? The diameter of that hole is 6 millimeters there. Okay, so I actually want to pattern 33 millimeters plus 6 millimeters is the distance from the center of this hole to the center of that hole. Just do the math there. Okay, so let's come back to assemble. Go to constrain. Well, not constrain. I'm sorry, I was patterning. Go to pattern. Well, again, don't forget to click on the rectangular pattern. Select this component. Okay. And now the columns again. I'll click the column. One goes that way. click the row now and say one goes this way. Select on this edge here. Okay, now how far? Notice if I went 33 was the distance between the closest faces or the closest edges of the circles. That's not far enough, is it? Okay, not far enough. So it's actually 33 plus the diameter. So 33 plus 6, 39 there. Alright, so hit 39. This is the distance between the two, between the patterns in each direction, and click OK there. Alright, so I've got those bolts placed. Okay, it's very nice. Now, notice, can I click and drag them? Nope, they're still all constrained. Okay, that's very good. Very, very good. Now let's go through and place these bolts, or sorry, these nuts here on top. Okay, let's look at that. Alright, number 5, it's a nut T6177. Okay, now these files are the nut file is inside the folder that you downloaded from Moodle, so you could place it from there. But I want to show you another thing. Okay, so what if you're actually creating an assembly and you say, well, there's nuts and bolts that are common. I don't want to go actually make a nut and bolt. I actually have to draw it in Inventor. Well, Inventor has a library of common parts. So if I click on the drop arrow here, drop down arrow for place components, I can click on this place from content center. Just click on that. Your computer will think for a little while here. It's just trying to call up the library of components. Okay, it'll come up here. Now, this is very neat. Autodesk Inventor has a huge library of different components, of cap nuts, all different types of nuts, all different types of bolts here that you can just select and place in your assembly without having to draw each of these here. There's all sorts of different things. There's other types of parts. There's drill bushings here. There's O-rings. Okay, sealing rings. There's even different sheet metal parts here. Again, different types of nuts, standoffs. Okay, lots of different common things that you would go buy at a hardware store. You could even look at different fittings if you're doing piping. They have different couplings here that you can place in, different elbows, nipples, nuts, again, lots of different things, some reducers. So lots of components here. You can take advantage of this with your project if you would like. Okay, you don't have to draw every part. If they have it in the have it here, you can use it. Alright, so I'm actually wanting to place a nut. Now, not a cap nut, I'm wanting to place a hex flange nut. So I can select on that. And the hex flange nut that I'm selecting, which kind is it? Let me go back to here, number 5. It's a nut GB T6177.1 M5. Let's go find that. Alright, 6177, yeah, one of these here. Okay, 6177.1 I believe is what it was. So here's a nut. I can click on that. That's the nut GBT, and you can see what it is there. Hit OK. It'll think, yeah, do I want to place it? Yes, click one time. Okay, and now it's going to ask me for what size, right? Do I want the 5 is 5mm diameter for the inside hole. M6, what size of nut? It was a M5. You see that right there? M5. So I'll have the M5 selected. You can select other types here again, different height, diameter, width across the flat. You could change these if you wanted to. Okay. Let's click OK. And so now I just have a part now that I can place. Click once, hit escape, just like I was using the part from like a part that I would draw. Okay. So I can use this to actually constrain it now. Now, one thing I like to do is I actually like to go save these parts to the folder that I'm using. I like to save this part to the same folder where all the other parts are, because this is the file for this nut is actually still in the content center. Okay, I'm going to right click and click on open. Okay, and notice it actually shows you how this part was made. I could drag the end of part up here. Okay, sorry about that. And you can see how it's made. There's the ring, they did an extrusion, did a chamfer, okay? So it's kind of neat to see how it's made. But I opened it so that now I could go save this part. Save as, sorry about that. Let's go save this part. Notice where it has it saved, it's way up in Inventor's Content Center files, okay? Well, I actually want to go put this in the same folder that all the other part files that I'm using in this assembly are. So navigate back to the same folder. Long ways here, piston press for students. There we are. So let's come save it here, okay? So I'll click save there. Do you want to well, I've already got one in here. Okay, yeah, sure. Let's replace it. Okay. So there it is. I'll close this part now. Now, I'm going to actually delete this part here because this nut is actually being referenced to the nut that is in the Content Center folder. Okay, but I want it to reference a part that I just saved into my folder where all these other files are. So I'm going to right click that and click on delete there. No, I don't want to save additions. Okay. So now let's do place, a normal place, not place from Content Center. And I can go find that nut. Okay, notice this nut is now in the Piston Press for Students folder. Okay. Hit open there. And now click it. Okay, again, the reason I did that is because I want this nut file to always be in the same folder as all the other parts in the assembly. Okay, and then I can add a constraint. So again, I'll constrain this axis with the axis of the rod. Hit OK there. I can still drag it up so that now I can constrain this face with that face there. There you go. Okay. Oop. Seemingly I missed a constraint. I guess it did not. Oop. See what constraints it added. Seems like that mate constraint has not worked. I can still slide it left or right like that. You see? I'm going to delete this constraint here. Let's actually try that again. Okay, so not joint. Sorry about that. Click on constrain. Constrain this to there. Okay. Well, the constraint's there. I guess if I drag it and I let it go, it actually snaps back. You see that there? Okay. No problem there. Okay, sorry, I thought the constraint was actually deleted, but it's still there. I can drag it away, but I can let it go. That's no problem. Okay, now let's actually pattern this to 4 places now. Let's click on pattern, rectangular pattern. I want to pattern this component. Which way? But not that way. Let's go this way and this way. Again, a distance of 39. Hit OK. There it is. Okay, so we're doing good. Okay, now I've got to, well, let's put these on the other side. Okay, you could use mirror. Now, I want to show you one thing I don't really like about the mirror function or the mirror feature in the assembly environment. And one thing that'll be helpful to do that. First, let's come up. Is it inspect, model, not there. View. Okay, go to your View tab here and click on this Degrees of Freedom. Okay, so I'll click on Degrees of Freedom, and you can see these little arrows that pop up here. What the Degrees of Freedom shows is how are you still able to move each part. Okay, you see this little, it looks like a couple vector. Okay, what that means is that I'm still able to rotate these nuts right here. So I cannot move it up or down. The only thing I can do is rotate it. So you can see the degree of freedom is rotation. Okay. The same thing on this body. I can rotate it. There's that degree of freedom. Now I want to show you what happens if I use the mirror feature. So go to Assemble, go to Mirror. Okay. Let's say I want to mirror these nuts across the middle to this side here. I would like to do that. So the components. What components here? There you go. It's these nuts. So select this one, this one, this one, and this one. So I've got those 4 nuts. Now the mirror plane. I'll select this arrow to now select my mirror plane. Just click on the cylinder body. That's the green part. And I'll go find that middle plane. So click on Origin, not those, that plane right there. That goes through the middle. Okay, now I'll click on that and hit Next. And then click OK. Well, what do you see that's different between these nuts and these nuts? Well, the difference is you see all the degrees of freedom. Notice I can click this one and drag it anywhere. Right? I can still rotate it. This has 6 degrees of freedom. Okay, it means I can translate it in this direction, or this direction, or rotate it in any of those 3 directions as well. And that's not very good. So when you actually use the when you use the mirror feature in the assembly environment, the constraints are not carried along with it. And I don't really like that. That's not very good because it means you have to go add all the constraints again. Okay, so probably the best thing you could do is just use the regular pattern and just find out what's the distance between this face and this face maybe. You could do that. Maybe for more practice you could just do the same procedure on this other face here as well, so that we did before. So I can just place, now let's go find the nut here. Okay, notice I'm getting the nut from the folder in my piston press. Hit open there, hit 1, and I'm just going to repeat the same process. Okay, so I'm going to click on the free rotate and click on the nut and actually rotate it to where it's in the approximate position before I place it. Okay, let's constrain, and I'll first constrain the axis with this axis. Hit OK, and it pulled it way down here, but I want to slide it up so that now I can constrain this face with this face, and I'll hit OK. There you go. Okay, fully constrained. Okay, so then I can go use the pattern feature again, just like I did. So I want to pattern this component. Now select the column degrees, the column directions, that direction, and this direction as well, for 39 millimeters and 39 millimeters. Now hit OK. Now if you see the degree of freedom, I can't click and move this. Okay, they're locked just like this one is. Alright, So that's nice there. Okay, almost done here with this subassembly. What else do I need? Let's come back to this picture here. Well, I need, okay, I've already placed this in, so item 1, item 4, 2, 3, 5, only one more thing, that's 6, and that's actually this sub-assembly that we've already created, okay? So let's come back here, and I'm going to go to place, and this time I'm actually going to select the sub-assembly that you've already, well, not that cylinder body, sorry about that, this piston rod sub-assembly that we already created, okay? So this time I'm inserting a sub-assembly rather than a part. So let's click once and now hit escape. All right, again, I'm going to rotate this to the proximate position. So click that and let's rotate it. It'll fit in about like this. Okay, hit escape. All right, let's start constraining this. Okay, so our typical procedure, I'll constrain the center axis with the center axis here. Now notice it doesn't matter if I do this center axis, this one, they're all the same axis here. Okay. Okay. Now I'm going to turn off my degrees of freedom. It's looking a little cluttered. Go to view. I'll turn off degrees of freedom. Okay. Now notice I can slide this in and out like that. Well, that's not how it will be in reality, right? In reality, when I actually slide this in and out, it needs to stop here and stop there because this piston comes in contact with the front and back cover. Okay, so I actually want to apply limits to a constraint now. All right. Now, notice I can't select anything inside here right now because when I put my cursor here, it actually wants to select that cylinder body. So I'm going to right click on the cylinder body and uncheck enabled. So let's click that. Notice it made it where you could see through it. It's transparent now. So now I can select these surfaces, okay? All right. So I could go to assemble and go click on constrain and say let's make this face meet with this face and click OK. If I did that, well, I can rotate it, but I cannot slide it in and out anymore, and that's not really what I want to do. Okay, so what I want to do is actually place a limit. I want to say this rod can slide from the position it's in now up to this face. Well, how far is that? Well, let's go measure that. So I'll click on inspect, click on distance here. I want to find what's the distance between this face and this face right there. Okay, see that blue line? That blue line is a distance of 35 millimeters. Okay, so I put the piston in the position where it's furthest to the left here. And now I say, well, what's the distance between this face and this face here? That's a distance of 35. Okay, so I'm going to actually delete this other constraint, that face constraint that I previously did. So go under the piston, expand the piston rod subassembly. Was it this one? No, that was the axis constraint. Let's delete this constraint here. I'll delete that. Okay, now I can slide this in and out again. So this time I want to constrain between here and here. All right, but now the difference is I want to actually use limits. Okay, the maximum and minimum. See, oh, excuse me. All right. So if this box does not display for you, click on these two little arrows right here. Those will actually expand or contract this extra, these extra options. These are the limit options, okay? On the maximum, I want that to be 35 millimeters, and I want the minimum to be 0. Okay, so I've got the maximum and minimum set. Let's hit OK, and now the minimum, there's the minimum, there's the maximum. So now I cannot slide it any further than the minimum and maximum. Okay, so this was kind of neat. Again, to review that, I just right click and let's edit that constraint. Okay, so again, I constrain, let's say, these two faces, that face and this face, and I said I want the minimum to be 0, which means they're on top of each other, they're contacting. I want the maximum to be that 35 millimeters, which is what I measured there. Click OK. That's good. Okay, so I've added constraint, or I've added limits to this constraint. All right, so I've made this subassembly, and I've made this subassembly already, again, which goes into this one. All right, so now I would just need to actually go through and make the main one now. Okay, so again, I've started from the bottom and I'm building up. Okay, I'm actually going to take a break right now, so the later part of actually finishing this lab, upload in another video. Okay.